Hey everyone, this is Mark, and this is Graph Theory. We'll be taking a look at a program called Heads-Tails Driver, which uses one aspect of graph theory known as an adjacency list. What this is basically a list of points or vertices and edges which connect to vertices. And the goal of this program is to find the shortest way to get from one state of coins to another. States in this case are just an arrangement of three coins, such as heads, 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 tails, heads, or tails, tails, tails. The rules for changing the arrangement of the coins are shown here, that you can flip the middle coin whenever it pleases you, but you can only flip the end coins if the other two coins are the same, such as them both being heads or both tails. And you cannot change the coins in any other way, like shuffling them around. Now, to accomplish your goal, you're going to want to set up a new vertex for every state possible, shown here. I just chose to put them all on a map to make them easier to access. And to create the graph, you have to compare each vertex with all the other vertices in the map, and if there is a possible transition between the two, following the rules shown before, then you make an edge between them, like shown here. After you've made your graph, you're going to want to find the shortest path to get to your goal. And the program does this by utilizing breadth first search. This method uses a queue to process each edge, starting at the beginning of the edge list of each vertex to get the shortest path. With this process, the path is built by set previous. Now here you want to be a bit careful. If the next vertex happens to be the same as the current vertex, or its previous vertex, then it'll result in an infinite loop. Once the pathway is built, it will send the final vertex back up here, and it will record that pathway into a string, S. And then right after, it'll print out begin, which is the name of the first vertex, and the pathway, then followed by the pathway here. Then you'll get a success message, and then you're good to go.